Yep. I think it's good now. We are good to start. Yes, friends, please confirm. You are able to see my screen, right? Please confirm, everyone. We'll slowly start now.
Yes,
Yes.
sir. Can we see?
Yes,
We can see your
Yep.
screen. Yes.
Perfect. Thanks for joining the call. We'll slowly start now. And see if we can have your observation notes ready, if possible. Okay. If possible, please get your observation notes ready. If you can, please. Yep. Let's get started slowly. And let me start the recording. Let's wait. Let me just make sure my things are set right. Please wait. Just wait for a few. Make sure. My... Yes. Everything is fine. Let's get started. And let me record this video. Let me record the class. Friends, see if you can write your observation notes or get some observation notes ready. Okay, and we'll start our session now. Perfect. Yeah, let's get started. Welcome to my session, friends. And today, let's understand the complete overview of Databricks. Let's understand from scratch what it is, how it is, and how to implement it. This is your Sai Fanindra from SQL School, and hope some of you know me already, just for others, everyone. Since my first job at Microsoft 2005, I have been into data stack and I love data. It is taking me to new paths, new things, learning new items every day and night. Awesome technology, data stack. And Databricks is one specific interesting technology that can help us to perform any type of operations pertaining to data from warehouse design to AI ML programming. For example, assume you have a database with you, but what next? You have an Excel file with you. What next? Databricks has an answer. Today we are going to learn what is Databricks, components involved in Databricks, the advantages, and the job roles including certifications. Let's get started slowly. To step into Databricks technically, we should know what is database first. A platform to store any type of data, any amount of data. And this database can be used to store usually live data, live real-time data, and a special type of database called data warehouse. We have OLTP to store live real-time data. For Databricks, we need something called warehouse to store historical data for analytics and data science concepts. Why like this? Let's get started slowly understanding it. Next two slides are very important for us to step into our practice items today. On my screen, the birthplace of data, files, websites, social media, IoT devices. From these birthplaces, data would be usually stored in OLTP databases. OLTP stands for Online Transaction Processing Databases. The green box, number 2 on my screen. What next? We cannot withstand the OLTP data forever. Remember that. We maintain the data in a database for last 1 year, last 2 years, like this, not beyond that. Why? Because if data volume increases exponentially, performance issues, maintenance issues, cost issues will occur. Assume something like this. Assume, for example, in your kitchen area, assume practically in our kitchen area at our home, in our house, few items are to be accessible quickly. So we put them in a nearby easy reach location, maybe just beside our, say, the burner or the stove, or very handy reach. Few other items may be procured from the market in bulk and you would like to keep them as a stock, maybe in a storeroom. May not be too far away, but yes, few steps away or few feet away. The storeroom is a warehouse. The quick accessible data is the OLTP. Let's take another example. Assume you go to a showroom to buy a bike or a car. The showroom is OLTP and we select the model, right? And we finish all formalities once we decide to proceed. And once it is done, the formalities are complete. My experience, they ask us to wait for some time, few minutes or sometimes even 1 or 2 hours, or sometimes until end of the day. What they do? Yep, they are going to get the actual final delivered piece from the godown, from the storehouse, maybe somewhere in the cellar of the building or far away from the city. It depends. My experience. That's nothing but the warehouse. The showroom is OLTP and the warehouse is nothing but the godown I'm talking about. And the transport system is ETL. Now the question here, where does Databricks fit into? As on date, again friends, as on date, Databricks fit into 3, 4, 6. 3, 4. The main skeleton and the body, and the actual cosmetic glamour added, that is AI and data science environment. Of course, not complete data science, but a part of it. I'll show you today in next few minutes, technically. Complete ETL, complete warehouse, part of data science is what Databricks mean. 3, 4 and part of 6. From here, let's understand why Databricks is so popular. That's very important from here. Are we clear so far? Please, before we proceed, please, I'll wait. 3, 4 and part of 6. Are we clear, please? Friends, mic with everyone. Please, I'll wait. Please. Yep, I'll wait.
Yes, sir.
Yep, Joshua,
Yes,
Mohan.
yes.
Yes, Naresh.
Yes, clear.
Sunil. Yep, others, Naimil, Ashwin,
Yes.
Indu. Yes, Kumar.
Yes, sir.
Friends, please. Yep. Thank you. Let's continue. So where we are now? 3, 4 and part of 6. I'll show you the so-called part of 6, but our main agenda is about 3 and 4. Yep, there are few analytic items in Databricks, and there is a dedicated certification for Databricks analytics. We call Databricks analyst certification. But again, when you compare other data analysis certifications or other data analyst job roles like Tableau or Power BI, ClickView, ClickSense, or Google Data Studio, Databricks again, we usually fall in love for its ETL and data warehouse caliber or its beauty compared to analytics. Let's see slowly. Now the question back, the actual question I was asking to myself few minutes back, why it is so popular, why it is so famous. Friends, here we should know some history. We should know some history to understand the power of Databricks. Yes, here it is. Databricks is a cloud-based platform for engineering and data science activities. But why? How? Let's see. Let me take you to my worksheet. And anyone planning to learn Databricks completely, you may take this screenshot. I could see few of you are already with me. Others who are attending public audience, yep, you may take a screenshot. I think in our ongoing Databricks course, we are here, right? Spark Declarative Pipelines, I think. Yep. I could see if you attend this from my ongoing Databricks 9 p.m. batch. Kumar, I think. I think Kumar, you're in the morning batch, right? 7 a.m., 7 p.m., 7 a.m. batch.
Yeah, 7
7
a.m. We
a.m.
are into ADF, Azure Data Factory.
Oh, yeah, got it, got it. Yep. Others, ongoing 9 p.m. batch, we are here now. And we need to take other things, so no worries about it. Everyone, in case anyone wanted to master Databricks, then the complete information on my screen for engineering and ETL perspective. Let's go back to our actual item, why Databricks is so famous and how it is actually into the market. It's very interesting journey. I still remember, friends, SQL Server. I'm talking from SQL Server, from Microsoft platform to start with, okay? I still remember SQL Server 2000 version. We used to have something called Black Book, SQL Server Black Book. And the author, Rob Vera, US author, Rob Vera. SQL Server 2000 is still there in Amazon now. And at that time, we used to have, okay, this is the OLTP. I'm talking about the OLTP, this one, friends. Okay, the OLTP, and I'll give you the ETL warehouse, both. So in SQL Server 2000, we used to have the OLTP environment as DTS. Remember, Data Transformation Service, ETL. OLTP is database engine, and ETL used to be DTS, Data Transformation Services, and Data Warehouse, again database engine, with SSIS extract, say, just database engine, no SSIS at that time. Then came 2005. Here, DTS and something called BCP also, bulk copy program. Database engine and came SSIS. SQL Server Integration Services. I'm talking from Microsoft perspective. Okay, these are all Microsoft environment. What about others? We'll take them slowly. Let's learn it. Here it is. This is, I'm talking about the Microsoft data stack for BI implementation. Next. And at that time, we used to have OLAP, Online Analytical Processing Databases. Remember, friends? Data warehouse is different. OLAP is different. Till date, it is different. both are not same. In data warehouse, we store historical data for easy analytics and reporting using tables and SQL activities. OLAP is different. Here we use cubes with MDX, DAX, DMX, XML languages till date since olden days. So we have OLAP, AS engine, simply say AS engine. Okay, something like this, just to make it clear. It is something like this. Okay, here you see something called as SQL Server, right? These are all database engine. Same way, we have other engines also, the integration services, polybase, analysis, etc. Next, that's fine. And everything go very happy, cool. At that time came SAP BW. And my God, like tremendous amount of like big data support from SAP at that time. I call it SAP BW. And they introduced SAP BW. We used to have something called SAP HANA. And SAP HANA introduced column store technology. I'll show you what it is very soon today in next few minutes in my agenda items today. Hence, I'm talking about the SAP BW. But what they do, yes, any BI, same process. Pick data from various sources, maintain data in OLTP, gather, filter, mash up, and theme the data into warehouse, and eventually land up into some kind of analytics and data science activities. Now, back to my track. And here we also have OBI, Oracle BI, and Oracle BI activities, enterprise reporting. And they started to support Hive because at that time, by that time, I'm talking about 2005 and 2003, at that time, Hadoop used to rule the entire big data market. I still remember in our high-tech city office in Hyderabad, we used to, go for full day data science course with 3 trainers. And we used to build Hadoop clusters. Perhaps that was the first time in my life we used to have night outs, building Hadoop clusters. But today, I'll show you next few minutes today, click of a mouse, we get the cluster ready with virtual machines. Thanks to the technology, here we go. I repeat again, we have Microsoft BI, at that time SAP BW, OBI, and one more used to be there again called IBM Cognos BI. At the same time, it also used to have good amount of market share for enterprise reporting, ERP systems. From OBI, Oracle, and OBI environment, a few modules were again given to Fusion, Oracle Fusion. And the whole world knows what happens next. That's a different story. Now back again here. Friends, we are learning why and how Databricks came into market. That is important so that we understand what it can do easily. Next, here we go. 2005 back, SSIS. And we used to have SSAS. Okay, and data warehouse, again, same database engine. Then came 2008 R2. In 2008, first 2008 came. Here again the same thing. And here they included something called tabular mode. Okay, something called tabular mode. SSAS. In olden days, In olden days, to step into warehouse, we need to pass through OLTP and ETL mandatory. With tabular mode given by Microsoft, Microsoft was the first company to introduce tabular mode. From data source, we can directly get the data to warehouse, bypassing OLTP, bypassing ETL. That's the talent of tabular mode. Next. Same is a case with 2008 R2. These are all the versions. And here we have something called Power Pivot mode also from Excel. So Excel and SQL Server, again, they started to gel together. We have something called Power Pivot mode. And then came SQL Server 2012. And by that time, cloud came into picture. I mean, the era of cloud. So in SQL Server 2012 version, by that time, we have, of course, database engine. For ETL, they started to use ADF also. Azure Data Factory version 1, remember. What about data warehouse? Yes, we have local database engine and Azure SQL Server. Inside Azure SQL Server called Azure SQL DW. Now we call it Azure Pool. SQL Pool we call it. That's a data warehouse, remember. And OLAP, same. And the story continued for SQL Server 2012 and 2015 version. And SQL Server, we have 2022, 2015, 2017. And we have SQL Server. I'm just coming to the points right now. 2017, we have 2019 version also. But there are few issues with 2019. Then came 2022 version. Then came 2025 version. And this is the latest one now. This is the latest one. And here we are into version 2. And we call this SQL pool. And you know what? This tabular mode is given to Power BI. This is the actual point we should understand. Yes, today, to do OLAP design, there are two services from Microsoft. One is Azure Analysis Services and other one is Power BI. Many people think, okay, Power BI is more into reporting. Correct, but not just reporting. Remember, it is into data mining, forecasting, cube design, and tabular mode implementations also. I'll definitely try to make a master class on exclusively Power BI for OLAP. It's very interesting, very, very interesting. And good to know all this. Let me now come back here. What we are learning? Yes, this ADF, Azure Data Factory, is user interface. Awesome. Nice drag and drop activities. The ADF interface is more into pick the data from wherever you need and then do all types of transformation, something like this. Pick data from multiple sources, do all types of transformations, and finally load the data to required destinations. We call them sink. Usually sink will be a warehouse in general. So ADF has ultimate number of user interface options, but small problem in ADF. Cost. Yes, till date, cost is a concern in Azure Data Factory when working with bigger data loads. So companies need a solution for cheaper ETL. Okay, that is first thing. Number two, by this time, especially in 2005 to 2021, 22, in between here, there was an understanding from all data platform companies to select one particular component as a hero for entire big data stack, and that is called, friends, any guess? Any guess?
Databricks.
No, my dear friend. I expected the answer. No, Spark. Remember, friends, Spark is the actual hero here. Okay, really, friends, Spark is the hero. The movie name is Databricks. Hero name is Spark. Really, friends, Spark is everywhere. Now, one more thing. Other side of the coin. Again, there are multiple shades here, friends. There are multiple shades. When cloud is evolving much, okay, Microsoft came with their own data centers. They are right now 100 plus data centers for Microsoft across the globe. 20 plus data centers only for Snowflake. From Microsoft, I'm talking about, okay? So we have Azure data centers. And at that time, there are few reasons. Let's not go into them. There are few reasons. Oracle and IBM could not have cloud data centers across the globe. So came Amazon data centers and Google Cloud data centers. What they do, friends, very, very important. The Spark is implemented inside the data centers. Remember, in olden days, we used to have Hadoop storage environments and Linux operating system to install Spark. Now, this Spark is integrated inside each of these data centers. And friends, observe carefully. Very interesting, but we need it. And who is going to use Spark? Yes, now comes our actual concept. The Spark is there, right? Spark is taken care by this a platform for big data processing. Spark is a platform. It's a programming environment actually that can process huge volumes of big data. And this Azure data centers started to use Spark for Azure Data Factory. Even till today, the Azure Data Factory data flow activity runs on Spark only. I repeat again, Azure Data Factory, ADF, Azure Data Factory data flow activity runs on Spark. No Spark, no data flow. Same way, friends, very important here. Now, slowly we are into our concepts now. So here it is. In Azure data centers, they give birth to something called their baby product called ADF. Now became very big, this one. Okay, we have something called ADF here. Similar to ADF, this is ADF, Azure Data Factory for ETL. Same way, in Amazon, you have something called Glue. Okay, Amazon Glue. It also uses Spark. Without Spark, no Glue components. Amazon Glue. Next, same way. Friends, we are slowly stepping into Databricks. Same way. Here, we have Google Cloud. Let's see. If it is Google Cloud, I'll just take you once again here. Okay, something like this. Okay, here interestingly, we call it Google Data Flow. Google Data Flow. GDF, or simply say Google Data Flow, we call it. Here in ADF, there is a data flow activity. Here we call Google Data Flow component. Good to know these things for our interviews. Understanding the job descriptions and client meets, technical client meets, project meets. Good to know all these. GCP data flow in simple terms. Next, from here, one more thing, we also have something called data proc. Okay, there is a data proc, Dataplex, etc. in Google Data Center. Somebody we Google Dataplex, data proc, and we also have something called data fusion. Very, very powerful. Data fusion. Okay, from Google. Next. So they have their own ETL products. Fine. And they run Spark in their own data centers. That is one style of ETL. So instead of using traditional local SSIS or local SFBW or OBI or IBM Cognos environments, things go cloud. Next, remember the hero is Spark. And additionally, we have something else called Databricks. Now the actual story starts. This Databricks environment, we have something called Databricks. This Databricks, again the same process. Databricks is an open source environment designed by one SFO, San Francisco based company. This particular Databricks is originally for ETL. Now comes even ML and analytic activities also. What this particular Databricks will do, very simple and straight. Databricks also used for ETL activities. So whatever you do using ADF, Azure Data Factory, or Amazon Glue, or Google Data Flow, we can do the same using Databricks also. Databricks is a platform that again uses Spark. We call this serverless compute, we call it. It's a cloud computing model. Remember, to process, for example, 1 plus 2 equal to 3, I need some calculator for it, maybe my brain calculator or mobile calculator or some other mathematical calculator used by my kids at school. To do some calculations, we need a calculator. To process some data in cloud, we need a cloud computing environment. That cloud computing environment is given by Spark. There is no alternative for Spark. Spark is everywhere in every cloud. Now, here we go. Question arises. Why Databricks came and in what scenarios we need to use it? Why not we go for ADF or Glue or Google Data Flow? Remember these items carefully. Very simple and straight. Databricks is just like an egg. Okay, remember, egg. In one kitchen area, you make an omelette out of it. In other kitchen area, you can make a boiled egg. Or other kitchen area, you can make a scrambled egg. That's the power of Databricks. A powerful environment that can be used in multiple cloud environments for different purpose. I repeat again. I understand. Take some time. Let's observe it carefully. We have Azure to process the data. Amazon to process the data. Google to process the data. That's why you have data engineering, right? Azure data engineers, Amazon or AWS data engineers, and Google data engineers. Don't ask me about Snowflake here. Snowflake does not have their own data center. Snowflake depends on one of these three data centers only. I'll show you. Let me just show you now itself, because I may tend to forget the point, okay? Remember, if you ask me, Sai, what about Snowflake? We have Snowflake data engineering. No, no, no. Snowflake is a flight. It does not have its own airport. Let me show you what I mean. Friends, every technology is great in its own way. And we should know when to take an airplane and when to go to airport. On my screen now, you sign up to Snowflake. It will ask you for one of these three providers. These three are the big brothers. The session is being recorded, and I'll be very, very frank and straight. These three people knows how to prevent others from entering the ring. I have multiple examples for it. These three people know how to prevent others entering the ring. I have multiple citations, examples, references for it. Now back to our point, friends. We should know, we should think bit big, okay, to step into it carefully. Again, everything is great, every technology is great in its own way. Snowflake depends on one of the clouds. Same way back, Databricks. The Databricks company joined hands with AWS. They joined hands with AWS. So here it is. The entire Databricks capacity, we say serverless compute. Those serverless computes are actually given by AWS only till date. So whenever I log into databricks.com, by default, it is with AWS only. Remember, it's a default and we cannot change it as per the architecture. That is one way of implementation. Other way. This Databricks can be something like this. Okay, this Databricks can be, just another 2 minutes, I'll give full clarity. Observe carefully. This Databricks can be inside Azure data centers. That is called Azure Databricks. Okay, here it is. It can be into Azure database, something like this. So there are two options. Amazon has its Databricks anyway, it's fine. Again, the same thing, GCP, its own Databricks. Yes, very simple, friends. Very, very simple and straight. Sometimes in our Hyderabad cities, or when I go to my hometown, okay, Andhra Pradesh, I see in shops and even roadside, they sell batter. I buy the batter. I'll call mom, can I bring some batter because you are a bit busy or a bit occupied. So no time to prepare the batter. Can I bring? Yes, Bobby, please bring. I'll go with batter at home. And they can make some idli out of it, or some dosa out of it, or some roti, or something else with the batter, something like that. The batter is Databricks. Simple and straight. Very, very quality standards being maintained. Now the question comes, Sai, if ADF is already there in Azure, why Databricks? There we are. I was telling again earlier, ADF has nice user interface, but some limitations with respect to customizations. For example, in ADF, we have, was mentioning few minutes back, something like this. In ADF, we have certain predefined transformation size, this one, join. But join will only take 2 tables at a time, not more than that. That's a user interface design. surrogate key. By default, it takes one identity key automatically. Go by design. What if you want to customize it? Yes, such customizations, Databricks can do it for us. That's the actual concept here. Same is a case with Amazon Glue as well as Dataflow also. So, in real world, Databricks alone, Databricks alone can do few activities, and in few other cases, Databricks flavored with respect to ETL technology like this. For example, something like this. See here. Okay, in this way, something like this. Why to use Databricks customized ETL, big data ETL, cheaper ETL. Okay, remember, see here, cheaper ETL. Then why to use data factory or glue or data flow? Yes, we have one more thing, cheaper and flexible ETL. Here, easy ETL activities and data orchestrations. Easy data orchestrations. Orchestrations mean if something is there, then you would like to do something else. For example, whenever a file exists, it's easy in ADF or Amazon Group. And the other day I was working on data flow with one of my participants. She was showing me how to, because I don't have any experience on Google Cloud. I never had experience. So I was working with her and she was showing me online how easy it is, just like ADF, how easy it is to check for the file existence. Check if file exists. Yes, it is there. Then give it to Databricks for actual ETL. Check if file exists. Read the metadata. It's very easy to read the metadata. You don't need to write big programs in Data Factory or Amazon Glue or Data Flow. Everything is ready-made for us. We can use it. Once we do the required initial items, then we go for the powerful Databricks activities. Now let's see what we do inside Databricks. Remember, first thing, I'll show you this item. This link I said, right? AWS. I'll show you this item first. Then I'll show you the advantages of Databricks. I must give it in a different color now. Yes, it has more options. Friends, very simple and straight. There's nothing new actually. Nothing new. In olden days, we have SQL, right? And Microsoft got it as MS SQL. And some other Oracle got it as PLSQL. Something like this. IBM mainframes. Same SQL add-ons and name them in a different way. Same thing here. Same thing happened here also. Open source Databricks is now Azure Databricks in left, Google Cloud Databricks right, with add-ons. From here, let's understand now the overall regular Databricks interface. Remember what we are doing here? It's all about ETL for warehouse design. One more important, very important point here. I'm talking about Spark for cloud computing activities. But what about storage, warehouse? Yes, very important. Here, Databricks support something called Spark databases. What are they? Something called Spark databases, also called Spark schema. We have Spark Compute. This is left side, it is Spark Database, and this is Spark Compute. Spark databases are different. Spark Compute is different. I'll call it Spark Compute. Just like SQL queries, SQL database. Same thing here. SQL queries are different. SQL database is different, right? SQL database is storage, and queries are for operations on that database. Same thing, same way, Spark Compute, Spark DB. So Databricks supports Spark databases. There are certain limitations. So this Azure, Amazon, and Google Cloud have their own data warehouses. In Azure, we have SQL Pool Data Warehouse. Same way, here RDS, Amazon RDS we call, and Redshift. We are talking about warehouse, it should be Redshift. RDS is OLTP, Amazon Redshift. Next, same way. What about Google? Here it is. In Google also, we have the warehouse environment, something like this. Okay, and we call it as Google BigQuery, this one. Hope you heard about it a lot of times. Google BigQuery, nothing but the warehouse. BigQuery is not a query, okay? It's a warehouse. It's a technology, storage technology. Fully serverless, we call. Okay, next. And BigQuery has its own ML called BigQuery ML, which is doing good in the market right now in UK and especially in Ireland. I could see a lot of openings for BigQuery ML. Fine, back to our point now. I repeat, Azure, AWS, Google, they have their own cloud-based warehouses now. This SQL pool from Azure, Redshift from Amazon, BigQuery from Google, those are alternatives for Spark databases. And either Spark database or SQL pool, Redshift, BigQuery, these are all data warehouse, remember, data warehouses. Spark, ETL. And apart from that, Spark Compute, ETL, Spark DB, SQL pool, Redshift, BigQuery are the warehouse. Now comes the final image. We have OLTP. Okay, we have OLTP here. This OLTP environment, I'll mail you all these items anyway, okay? For your easy reference, I'll also include the video. I request you to go through it multiple times. It's good if we can go through it carefully, because we don't know whether we again hear this again, right? Anyway, we don't know. So good to know it. OLTP. Inside OLTP, we have multiple sources like files. Okay, we have files, and same way we have, just wait, okay, something like this. We have files, and same way we have, for example, I just give the regular activity here. Next comes, for example, spreadsheets. Next, we have something like, for example, OLTP databases. I'll generalize the items now. This is OLTP. The source can be anything. OLTP. Next, I'll divide it separately. In real world, usually OLTP layer will be separate. And next, we have websites and apps. Okay, so web and social media, they can be source, or apps, These are the different sources we have. From these sources, data would be sent to OLTP. Friends, now we are learning from technology perspective. So this is OLTP environment. What is there in OLTP, please? What are the technologies that can implement OLTP, please? Please, I'll wait. Mic with everyone, please. This is a data source. Yes, friends, please. Technology is implementing OLTP, please. You're aware of it, please. I'll wait. Yes, please. SQL Server, right? SQL Server. Anything else?
Oracle.
Yes, we have Oracle. Next. Next.
MySQL.
Postgres, MySQL.
Okay, MySQL or Sybase, Ingress, others, including Amazon RDS. Okay, next. Again, here in OLTP, we have cloud and non-cloud. I'm not going into that right now. I'm not going into that, just say regular products. Next, from here, we have ETL. We are talking about Spark, right? Where is Spark? Let's see carefully, just to make it clear for us. We have the ETL environment. Okay, this is the ETL environment and data warehouse environment. Usually ETL warehouse go together. So this is a place where Databricks come into picture. Okay, ETL and data warehouse, they actually sail together. Yes, in olden days, we used to have ETL separately, warehouse separately. Best example, Hyperion and Teradata. But cloud, non-cloud activities. Now everything into cloud, right? And big data. So ETL warehouse, they actually sail together. Now, here it is. We have Spark databases and Spark computes. Okay, here it is. For any ETL, we require Spark compute. The Spark compute is required to power both ETL, remember ETL, as well as warehouse. Both it is going to power or give the required resources. I'll show you in another 5-10 minutes, practically with example. Next. Here we go. In next 5-10 minutes, I'll show you practically this complete end-to-end example to make it easier for us. Now, here it is. Okay, Spark compute, Spark warehouse. Come on, friends. What are the other warehouse we have? Please, you remember? Azure SQL pool, right? Azure SQL pool, DW. And we have something called, come on, what else we have, please? Other data warehouse technologies, please. I'll wait.
Redshift.
Redshift, Amazon Redshift, or simply say Redshift. And same way, Google BigQuery, etc. Warehouse environment. So this is a storage department. Okay, this is a storage department. Next. Using Spark compute, we have ETL department. What are they? ADF. Okay, remember, in Oracle, there are few ETLs, but not as popular as the ones you see here. These are the three main data centers we have for big data stack. So data engineering profiles evolve from one of these houses. Azure data engineers, Amazon data engineers, Google. Don't ask me about Snowflake or Fabric. Those are different story again. They don't have their own data centers. They have to depend on one of these data centers only, including Fabric, remember. Now, next, we have ADF. Okay, there's something called Amazon Glue. Next, and we also have something called data flow. These are the ETL environments. Next, to implement ETL with the help of Spark Compute, very important to start our practice now. We have something called as notebooks. A new term for us called notebooks. Data factory, we have something called pipelines. Amazon Glue, we have pipelines and scripts also. Data flow, we have pipelines and scripts. From Databricks perspective, we have something called as notebooks. Okay, here it is. The ETL artifacts we call. For ETL artifacts, when working with Spark Compute, we have number one, okay, this one. Spark Compute is again implemented by Databricks now. Spark Compute can be implemented by Azure, AWS, Google Cloud also. We are now learning how to make use of Spark Compute. Here comes something called notebooks and something else called pipelines. Pipelines, notebooks. These are the very common artifacts used by Spark. Now let me show you how to build or how to get the Databricks environment, verify the compute. This one now. How to get Databricks? Our agenda is this one. Databricks. Then get a compute. We can build our own compute or use a default existing compute. Get one Spark database and pull data from green SQL server. How SQL server gets its data? From some files or sheets or web or social, etc. Okay, once we get this data, what next? Power BI reporting. So I'll show you now how to get the data into Power BI report, end to end. Remember, we are into open source Databricks. Definitely, I'll try to make up my time in next a few weeks for exclusively Azure Databricks end-to-end plan, and also we have Azure Data Factory to Azure Databricks two-way communication. One masterclass should be enough to take Databricks in Azure and ADF. We'll definitely plan for it. Next week, we have masterclass with a different trainer on SQL concepts. So mostly later next week, we have Snowflake masterclass with us. So maybe after that, I'll try to take this one for you. We'll see. For now, here we are in open source Databricks. I'm not touching the Azure Databricks as of now. But one thing, Azure Databricks has its own certification, DP750. Okay, just in case anyone interested to know. And here it is, Databricks Data Engineer Associate exam. Okay, so two different certifications. And as you can guess, majority concepts are similar. But one from Microsoft with ADF. DP750 has majority Azure Databricks with Azure Data Factory. That is DP750 exam. Databricks Data Engineering actually involves reference to All three, remember. Yes, Databricks Data Engineering Associate Exam Certification course content. I just looked at it recently, a couple of days back, and I could see the reference to these three houses. Okay, good to know. Let's continue now. How to first get the data from file to database, database to ETL, ETL to Spark, Spark to reports. Okay, first, let's get the Databricks environment ready. You already have it with you. It's okay. If not, get it. How? Very simple. Go to this website, databricks.com, and first time sign up. This one. Sign up and free. Okay, lifelong free. Databricks is open source, right? Lifelong free. Come on, friends. Who is supporting the infrastructure of Databricks by default, please? Do you remember which company? Which
Amazon.
cloud environment supports, which cloud hosting provider, which data center company provides the resources for Databricks by default? AWS, right? You remember, please? I was mentioning it. Please, everyone, please. I'll wait. Yes.
AWS.
Here,
AWS.
Yes, sir.
go to Workspace or OpenShare ID. There you see click, and you see the AWS ID. This East US. That is one of the limitations. What if my client will say, Sai, no, my client is in India. I don't want to read data from East US data centers every time. What I do? Then I'll say, okay, client, don't go for open source Databricks now. Let's host Databricks in our own South India or Central India region. That is a concept here. Instead of depending on default East US AWS data center, we can customize Databricks to be hosted in our own nearest data center for the majority of the customer base. That is the beauty of customizing the Databricks. For now, again, we are sticking to open source Databricks right now. I'll try to make it mostly by next month itself, ADF with Databricks, and I'll use the same sheet to continue at that time for this item. For now, so let's stay tuned. For now, let's go to open source Databricks. Okay, we verified this link. I just want to verify this link. Whatever we get in the diagram, let's verify it first. Verify it. Back. Okay, my Databricks ready. Where it is? Yeah, this one. My Databricks ready. Now, inside Databricks, I gave two different options. What are the two different items? Left side Spark database, right side Spark compute. Go to compute. You see by default, in olden days, we used to have automated compute. Very recently, few days back, just a few days back, they introduced interactive compute also. For now, okay, both are available. For now, make sure your automated compute is there, and okay, make sure the compute is ready. This one, automated compute, it's mandatory for us now. What does compute means? It is a Spark cluster. It's a Spark cluster. For what? For processor memory resources. I repeat once again, to do some processing, we need a calculator. or mobile for any kind of calculations. Here in cloud, we use Spark clusters to do the compute activities. If it is branded like Azure Databricks or Google Cloud Databricks, there we can customize our own compute. Here we go with the default compute supported by AWS environment. We pay to Databricks. Databricks will pay to AWS for paid accounts, company accounts, enterprise accounts. You and me, for now, we can make use of lifelong free account. It's okay, fine. Next, compute ready. Make sure it is available. Next, one more thing, friends, serverless. Serverless means you and me, we don't have control on the compute. That is serverless. What's the other one? If it is, for example, Azure Databricks, we have serverless plus classic model we call. Classic model means full control on the Spark cluster. And the clusters are actually implemented on Ubuntu operating system, Linux environment, Ubuntu. That's why Linux is very famous for big data. I repeat, Linux OS, Ubuntu environment. And inside Linux OS, Spark will be installed. And once Spark is installed, then Spark compute components, Spark database components will be configured. That's what we do in Azure or GCP. That is classic deployment. Here it is serverless deployment, serverless compute. I'll write here, this is called classic compute. Okay, by heart these things carefully. Classic means you build, assemble the things. Okay, that is classic. Serverless means ready-made. Just like that. Ready-made computer, ready-made PC, assembled PC. Something like that. For now, serverless ready. There is no classic model in Databricks, open source. We have only serverless. You go by it. And now, what next? As per our diagram, we require Spark database also. Go to catalog, create catalog. Catalog is like an instance. Remember, just like an instance. I'll say SQL School test catalog. We can create multiple catalogs in Databricks. Now the question comes, okay, you can have multiple databases. Who is going to control all these catalogs? Who is going to allocate the processor, memory for all these catalogs? Unity catalog we call. Unity catalog is a centralized repository, centralized metadata controller that stores permissions, that stores all types of metadata for easy access. My catalog ready. Remember, catalog is like an instance in SQL Server, something like that. Instance means like my house. My house has multiple rooms. My catalog has multiple Spark databases. Let's see. I created the catalog. Now, new notebook. I said notebook is an artifact. New notebook. We have something called SQL notebook. And use catalog name. Remember, catalog is like a house instance. Inside catalog, create database, Spark database. Any name is okay. It's up to you. Remember, we are using serverless compute. to work with these statements. It's selected automatically. May take some time for the first cell to be executed. And now create. Okay, done. Database got created. What is this? It's actually a warehouse. Remember, Spark database is nothing but a warehouse. Use Spark database. Initially, no tables, show tables, control enter. Okay, no tables, 0 rows. Okay, our warehouse ready. So using compute, we got the warehouse ready. Okay, I'll just put this one to make it easier. So using compute left, you got the warehouse ready, right? Or the SQL Spark database ready, this one. Now let's see how to read data from a database, write it to Spark DB, OLTP to Spark. You can ask me, Sai, why to duplicate? No, we are not really duplicating. It's a process of data archival. Active data from OLTP will be given to the warehouse on incremental basis, so that OLTP can focus only on operational data, not the old data. All old data will be given to Spark only, or the warehouse environment only. So here it is. Let's understand slowly, step by step, how to do this now. Let's understand here the main purpose of data factory or glue or data flow plus Databricks. Remember, everywhere Spark is common. Okay, so okay, we got the Spark DB ready. Now let's continue the next example. You can ask me, why ADF, why Databricks, what is what? Here it is. Same data sources and same OLTP. And here is the actual concept. We can make use of data factory, Amazon Glue, Athena, Amazon Glue or Amazon Athena or data flow, etc. here. This one. Just wait on my screen. ADF is the best to load data into OLTP. Remember this. ADF, Azure Data Factory, Amazon Glue, and Google Data Flow. They love OLTP data. They always love to touch OLTP data easily. It works for them. For example, assume you have a local Excel file with you. You wanted to load that local Excel file into local SQL database or an Oracle database. ADF is the best option. Next, from here, for example, you have the warehouse ready, this one. Our actual example now, the warehouse ready. Let's take, for example, Spark DB, okay, Databricks Spark database. Here it is. To load the data from OLTP to SQL pool, Data Factory is the best. Same way, here, Amazon Glue is the best because their architectures are similar. Example, Data Factory has something called partitions and distributions, which are similar to SQL pool architecture, partitions and distributions. It's not the case with Spark. Next, here it is. Same way we have Databricks. Open source Databricks I'm talking about. Okay, something like this. So depending on the target warehouse, remember this is not a rule, just recommended. Okay, just recommended flow because they gel each other easily. Additionally, if it is ADF, only ADF may not be enough. So you need Azure Databricks. This is the actual concept. Okay, same way. Here you have AWS Databricks. Something like this. Observe carefully. Why? For more flexibility, they actually gel together. Next, one more important thing. Snowflake. Snowflake does not have its own true data center or true ETL. It has to get some dependencies. So here it is, Snowflake. Well, Snowflake ADF will go good actually, no doubt about it. But in general, for more flexible activities, here it is. You can make use of open source Databricks alone for Snowflake also. Go through it carefully now. I'll wait. Okay, next. From here, let's see how to, okay, our database ready. Let's stick to Databricks, how to read data from an SQL server. Assume for now, you got that SQL server data ready by using some other ETL like ADF, assume for now. Let's stick to this Databricks environment. And let's complete that example. Please, are you getting it now? Please, I'll wait. Yes, please, I'm going slowly, step by step. Please, are we getting it now? Please, I'll wait. Everyone, please, I'll wait. Can you hear me, everyone? Please confirm.
Yes, sir. Yes.
Yes,
Are
sir.
you tired? Are you tired?
No.
Yes,
I am not.
we can. I can
I
hear you,
didn't have
sir.
my breakfast today and I'm happy. I'm using my yesterday's dinner energy only. Really, I'm not tired. Please, friends, please. Your response, my energy. Your response, my energy. Please. You want break? Let me know. You want any coffee break or tea break? Let me know. I don't want any break. I'm okay. I'm okay. Tell me. I forgot to drink water for last 1.5 hours. Let me drink some water now. In the meantime, please, any questions, let me know. Yes, any questions, please? Fine, friends. Let's continue. I repeat again. If your target warehousing environment is Azure SQL pool or Azure SQL warehouse, definitely it needs two ingredients in ETL, data factory, Databricks. Okay, to make it more easier, I'll put like this. I'll put this way. This is our Databricks and ADF and Databricks like this. Okay, same way Amazon Glue and Databricks, something like this. Yes. Fine, let's continue now. Let's see how to work with the extraction transformation load to Spark DB. I have my script ready with me. I'll include the script for you for your practice. If anyone interested in Snowflake, let me know. I'll give you separately. I have the script also ready with me. Read data from SQL Server. Through Databricks, write data to Snowflake. Anyone working on Snowflake, let me know after the class today. I can send them the script on WhatsApp separately. For now, let me show you how to read data from SQL Server, OLTP environment through Databricks, write it to Spark DB. As I promised, definitely I'll make my time to show you this item soon. I said data factory, Databricks together, right? This one. This is mainly for SQL pool. Fine. For now, let's continue. Let's continue how to work with it. Simple process. I'll mail you all the script and the details anyway. Go to Databricks platform. Okay. Catalog ready. Inside catalog, database ready. Inside database, as of now, no tables. Okay. 0 tables. Next. I'm going to give you one notepad, not notepad, see, a notebook, and here it is. I'll take it and aggregated data loads. Yep. Let's see, go straight into the items carefully. I think I have to take this one. We have file aggregated loads table, and I'll see if I can get it here. If not, we'll take it in a different way. File aggregated loads is there. Let me take table aggregated loads. Yep, this one. Or anything is fine, or incremental loads, anything is fine. Let me take one particular example. Fine. So initially, use catalog. Okay. Let me just make sure I connect to the catalog first. Inside catalog, whatever database we are created, let's connect to it first. Let's connect to it next. Okay. So catalog ready, connected, database, Spark database, warehouse ready, connected. Now I'll create one empty table, a warehouse table. Let me read data from my data source. For our practice purpose, I'm taking one server, SQL School online server. This is OLTP data source that runs on port 1433. This is my server I'm using for the data source. This is actually an Azure data source. Okay, Azure OLTP, database name, credentials. Next, let's see. I'll include all this script for your practice anyway. Let's observe it carefully. Here, what we do, simple. Remember these items, okay? URL equal to credentials equal to. And I think the credentials, I'll give some temporary credentials for now. Next, URL, credentials, and from there, we need to read data from the source and create a view. Let's define this table at the source first. I repeat, we got the warehouse ready. Now what about the source? Let's get the source. I said incremental loads, right? Now let's connect to this SQL server, configure the source. I'll make use of SSMS. My OLTP is SQL server, I should use Management Studio. If your OLTP is Oracle, we have to use Oracle Developer Studio. If OLTP is Postgres, you have to use PG Admin. MySQL, use Workbench tool. So depending on the OLTP, we need to use appropriate tool to connect and operate. In my case, it is Azure SQL Server. Connect to the server. And so database engine, okay? It's a database engine I was mentioning earlier. Next, new query. Okay, new query. I got my script ready with me. I'll just quickly show you the example. We are now configuring the source, okay? I'm taking the incremental loads. One of my examples from my Databricks class. Yep, this one. Create table, okay? This is the source table. We are learning the overall item end to end, okay? This is a source. Source inventory table, if it is already there, I'll drop and recreate. Yes. I'll create the table. Next, I have my own reasons to remove into. I love giving without into to reduce the network traffic. And next, select. Okay. Initially 4 rows. Where? At OLTP. Source ready. OLTP. Now the time is 9:31 AM India time. We have 4 rows. Okay. Let's forget the date. For now, time is okay. For our easy reference. 4 rows. Let's go to our Databricks platform. Using the compute, we are now working on the warehouse, Spark database. Okay, let's read the data. This is the source. URL equal to which URL? See here, this one. This URL is server, this one, server. Server complete SQL server.database.windows.net. That entire URL, table, inventory table. See here, the table is TBL inventory, my source table. Properties, credentials, username, password. And create temp view. Create temp view. Okay. So let's define the URL first. And then define the view. It says failed JDBC connection. Not a problem. I'll just quickly try to run it once again. Ideally, it should not fail. Let's wait. Let's wait for a few moments. Yes, it's already there. Already exists. Perfect. And let's save the URL. And it should not fail the connection. My connection is working fine, I believe. Let's wait. If in case if it happens again, not a problem. I'll quickly go for a new window and try to do this one. So I'll export. I'm using a free account. Say download. Download the complete notebook. And let me make sure my server is correct. Database correct, right? And SQL School online server. Let me make sure my server name is correct. This one. Perfect. Credentials, yes, everything is fine. It's working fine earlier. Let's see anyway. I'll try to rerun the script again. Let's see. Let me just rerun the script. Go to Workspace and I'll create a new folder. Inside folder, I will import, browse. For my downloaded script, open or import. Let's try this. If it's not working, I'll show in a different way anyway. Use catalog. Let's use catalog and let's connect to the database, Spark database. My table already exists. Okay, 1 minute. Let me just connect to the catalog first. Inside catalog, let's connect to the database. Yes, it's working fine now. Right? Okay. Inside this database, let's verify that warehouse table exists. Initially, select star from and table name, this one. Select star from table name. Yes, make sure no data. Okay, initially 0 rows. It's a warehouse. Okay, it's a warehouse. 0 rows. And get the URL. Let's verify. These are just variables. Okay, these are the Python variables or PySpark variables. And earlier we got a trouble here. Same problem. So it says create temp view. It's okay. And properties are fine. I think my properties. Let me check the password once. Okay. I think some problem here, the password. Let's wait. Let's wait. Okay. I'll try to define the connection password. I think 3216%. My bad. Sorry to waste your seconds. I have to provide the correct password for the connection. Now it is working fine. My bad. It's my fault. I provided a wrong password. I reset the password for our masterclass purpose, a temporary password. I missed few characters in the password that triggered the problem. Now it got addressed. View ready. So what does the view contain? Yes, the view contains the source table. Why? Yes, you are reading the source data into view. Why? For the purpose of upset, merge activity. So you all know SQL concepts, right? Merge concept. Attendees from my SQL classes, from my Microsoft SQL SQL classes, you are already aware of the merge statement. In stored procedures concept I was showing you something called merge. There again, same activity. BI model, purpose of ETL, purpose of warehouse, nothing but the big data and the need for merge. Friends, strong SQL foundation is very much required. The time has come. It is required. Proper foundation required. Next, merge into. So what it does, it is going to load 4 rows. Let's verify. Let's verify. So this is the initial load. Let's wait. This is the initial load. Okay. Next, go to source. Let me do few new row inserts, existing row updates. I'll include this complete document for your reference purpose anyway. I'll include this in the WhatsApp channel, the Databricks WhatsApp channel. I'll include it. Here it is. Where we are now. We need to have the insert statements. Okay. New row inserts, existing row updates. Where? At the source. Now the time is 9:39 a.m. Okay. So here it is. At 9:39 a.m. I got new row inserts, existing row updates. So after a few minutes time, initial load, few minutes time, then incremental loads. Let's see carefully. Yes, ideally, we are supposed to schedule the notebook for automated merge for our requirement right now. I went to the source. What is the source here? OLTP. Okay, perform few new row inserts, existing row updates, and then merge. I repeat, ideally, we are supposed to schedule this notebook. For our learning purpose, I'm doing it manually. Now verify it. Here you will see those two new row inserts, 5 and 6, and existing row updates. So what is the source here? My OLTP database. What is the destination? Warehouse database. Who is the mediator? Databricks PySpark environment. I mean Python with Spark compute. Python with Spark compute, and the entire Databricks is your actual house, the play area. So Databricks is a play area that includes multiple components. Yes, we tested the warehouse here. And next, the same warehouse content, we can also give it to Power BI. Let's see that. Before we proceed, let's understand now. From whatever we learned so far till now, let me put this way. Let me get the final definition of Databricks. Okay, that's our actual agenda, right? We are learning slowly what is Databricks. So Databricks is a platform. It's not a technology, it's a platform. It's a great platform with beautiful technologies inside it. Yes, inside Databricks, we have number one, Spark compute. I said serverless, right? This one, serverless and other computes. Next, we also have Spark databases. Spark computes and databases. Next, we also have something called notebooks and pipelines. Let's do it carefully here. There will be one or more computes. Depending on the requirement, you may see a small compute, means small set of clusters, or medium compute, moderate size clusters, or also there can be a big compute for big data processing activities. And we have something called workspace. Friends, very, very important here. There is something called workspace, and inside the workspace, okay, inside workspace, you have notebooks, pipelines. We also have something called scripts, okay, scripts. Let me show you this in the interface. What is it? Workspace. Let's see. Go to Databricks Workspace. This is a place where I imported notebook. Not only notebook, in a workspace, you have folders and files inside it. folders, files, and other content inside it. For now, workspace ready. Next, what else I did today? I created the catalogs, right? I created catalog, something like this. For example, you have a catalog here. Catalog is like a house. Okay, this is a catalog. Inside catalog, these are the storage items. Inside catalog, we'll be having two types of content basically. First, Spark databases, okay? Spark databases. Like this. Okay, like this, Spark DB. Next, inside Spark database, you will be having something called volumes. Okay, what is it again? Something called volumes. We have volumes, V for volumes, and we have T for tables. For our learning purpose, I'm saying VT. Okay, V for volumes, T for tables. Inside each database. This way, you have multiple catalogs created like this. Multiple catalogs. All these catalogs will be inside, all these catalogs are inside something called lake house. New term, we are going slowly. New term, a new item for us, lake house. A open source lake house. Next, apart from this. Okay, here this entire items are controlled by one additional catalog separately, a master catalog called Unity catalog. It is of course attached to the lake house, but will control everything. This is my headmaster, school principal, something like that. Next. From here, okay, my Spark database ready and the table ready. From this table, let's see how to get the data from the Spark database to report. The final part today in our class. I repeat before we proceed, Databricks is a platform. It has multiple technologies. It has Spark technology for Spark compute, storage technology, storage lakehouse, Spark databases. Database contain volumes and tables, and for operations we require workspace. One more important thing, it is attached to the Unity catalog, one important item called security activities. Okay, something like this, security. Security management, IAM, identity and access management, and tokens. These tokens and identity access management are mainly for the purpose of security. This token we are going to generate now for Power BI. Okay, let's do it carefully step by step. What is that? The token. Okay, T-O-K-N, token. Let's see. Let's understand how to get the data from Spark DB. Of course, a table to Power BI or Tableau, anything. Very simple, straightforward. Let's see carefully. Friends, I'll mail you all these items. Okay, see if we can go through it carefully. And forgive me, really forgive me if I bored you anywhere in between. My bad, my problem. It's not Databricks problem. It's great technology. Did you get bored? Any boring session or interesting? Let me know, please. Boring or interesting? Let me know. I'll conclude.
Interesting.
Interesting.
It's interesting, sir.
Perfect. Then fine. Then my subject is safe. I'll continue. Let's go to Databricks. I said token, right? Let's go to Databricks. Top right. Okay. Settings. There are different ways to connect. I'm showing a simple way. Developer. Here developer means BI developer, ETL developer, data engineers. Everyone comes under developer. Token. To access the Databricks API. Back. This is the Databricks API. Remember. Okay. These are the mantras we should be by hearting. So what does Databricks API contains now? Unity catalog, lake house, computes, tokens, workspace, etc. Including something called jobs. Also called workflows. Jobs we call it. Workflows or jobs. Okay. Just to make it clear for your interview preparations. Next. Okay, you got the API token, means entire red box token. What does it mean? It means using this token, we can access any catalog, entire lake house. That is a concept here. Back to my screen. Databricks API, manage, generate token. I'll say token for master class Power BI. Here, very important. Scope. Other API means all Databricks API components are accessible. BI tools mean only tables inside the lakehouse are accessible. SQL, only tables. Other APIs, tables, volumes, Unity catalog, and pipelines, jobs, notebooks, IAM, everything accessible. This is required for data factory integrations. BI is enough for Power BI Tableau integrations. I'll give some lifetime now, one, and generate a temporary token for our example. Copy, okay? Copy. Next. Once I copy, one more thing. Back to my screen. Okay, you got the token ready. Okay? Token ready. Next. One more important activity. This is not enough. Only token is not enough. I said compute, right? Isn't it? Compute is part of our Databricks API. Go to compute. Because without compute, we can't do anything. Compute is like a battery. It should be on. For the entire Databricks engine should be on. Go to compute. Here you see the required warehouse. Any warehouse is fine. Go to compute. And here go to the warehouse. Connection details. Connection details. Server host name. Copy. And HTTP path copy. Okay. Server host name. Next. HTTP path. Okay, like this. Next. server URL equal to formula HTTPS colon server host name. Okay, server host name colon 443 port number fixed slash HTTP path. Okay, here it is. Give the HTTP path. Okay, next. So copy the path. Remember server host name colon 443 port slash HTTP path. That's the server URL formula. Copy. Launch your Power BI. I'll include Power BI installation download link. Just download, it's a free software, Power BI desktop. There are different tools in Power BI. One of them, Power BI desktop. That should be fine. All Power BI tools support Lakehouse or Databricks data sources. Click on more. This one. Get data. This is a get data symbol. More. I said Spark is a hero, right? This one. Spark is the actual hero there. Okay. You have to talk to the hero directly through a movie called Databricks. Select the Spark. Connect. Give the server name. Which server name? This one, friends. You have the server name here, right? This one. Copy the entire server name. You can simply edit it in a notepad. It works in a notepad. Give the server name. Okay. HTTPS server host colon port number. Okay. Just wait. Where is our port number here? Just wait for a few moments. I'll take it in notepad instead of Word, instead of Excel. I'll take it in notepad to make it easier for us. Okay. In this way. Yep. You have the server host name. Okay. HTTP path and server URL. This is the complete server URL ending with 17. Next. No extra spaces. Protocol HTTP and click OK. Just leave the remaining as it is. Click OK. It will ask you for username, password. First time, username, password. Username should be token and password should be the token you generated few minutes back. Username, password. This is the process to connect. Remember, we are connecting to Spark database. Okay, remember that. So Spark is a technology. That Spark technology is Spark Compute, Spark Database, PySpark platform, everything within Databricks API. Remember. So Databricks is a shop and many products from one ingredient, Spark. That's how it is. Okay. Just like a breakfast, a tiffin shop. Many ingredients from the batter. The batter is Spark. Something like that. Now, here, just for our understanding purpose, okay? But good to have the examples as is. In our example today, we got the required notebook with complete warehouse ready. This one, incremental loads. So which catalog it is? SQL School Test Catalog. So let me go to SQL School Test Catalog. I think somewhere here it will be. whatever catalog it is, okay, just go to the catalog, go to database and select required table. I think the table aggregated loads or whatever, just give the required table, this one. I don't remember the table name, this one, right? Table inventory, something like this. Give whatever table it is, just select the required table. Just giving an example here. Anyone you select and then click load and report. Click load and report. Okay. Just during your practice, you provide the correct database name and warehouse name. I think this one, I don't remember exactly. Let me double check it once. Let me double check our Spark database. So let me give the Spark database. Yeah, this one. I think it's not coming up. It's not taking some time to refresh. Anyway, just select the required table, okay? Whatever table it is, just select it. Just an example. Select the required table. For some reason, I'll refresh and still I don't see that newly available database here. I think I'm using a free account. This is a process, okay? Just to get some idea. Select the required warehouse, whatever it is, and select the table and click load, Once you click load and continue the reporting activities as it is. Data engineers will be involved in designing the warehouse, testing the connections. Data analysts will be involved in continuing the reporting activities. Now, what we are learning here, how to read data from Spark. So Spark is a backend. Highlight Spark in your resume. That's very important. From here, we'll stop now. I'll mail you all this content. Please see if we can go through it carefully. It's good if you can concentrate on this Excel sheet carefully for the practice items, if you can. I'll include all this Excel file and the cheat sheet for the concepts for you to learn. In addition to additional FAQ questions and answers on Databricks. Everything in my WhatsApp channel. And you can just ping me on WhatsApp here to me directly. Your next step, just ping your hi message on WhatsApp and I can send you the link for the channel, and inside the Databricks exclusive Databricks WhatsApp channel, I'll be posting this Excel sheet, the video, and also interview videos time to time with additional FAQs or forthcoming master classes information. I'll be doing it. Just WhatsApp me. A hi message should be fine. And we'll take it from there. Preferably a hi and your LinkedIn profile if you can. Let's connect each other. Let's connect. You can also directly reach me on my LinkedIn. Just in case. We'll stop now. Thank you so much for attending my masterclass today. Thank you so much, and meet you soon in our next classes as we proceed further. Thank you once again. Have a nice day. Yep. Any more questions, please? I'll wait. Yes, friends. Thank you once again. Have a nice time. Any more questions now? I'll wait. Thank you so much for your valuable time today. Any questions?
Thank you, sir.
Thank you, sir. Thank you so much. Yep.
Thank
Next
you.
question,
Thank you.
please. I'll wait. Yep.
Sai, is the session recorded by any chance?
Yeah, it's recorded, madam. I'll send it anyway. I just send a small hi message on WhatsApp. Friends, you can WhatsApp me for getting yourself added to the WhatsApp channel exclusively for Databricks so that you don't miss the interview questions and other kind of events, master classes and FAQs, etc. In the same channel, I'll be posting the video also. I'll do, sure. Yep, I'll do.
Thank you. Thank you.
You're welcome. Thank you. Next question, please. I'll wait. And thank you so much. Have a nice time. No questions, you may leave. Any questions, please let me know. I'll stay back. Please let me know. I'll wait. Thank you, Indu, Jamin, Franklin, Kiran, Joshua, Kumar, Mohan, Naresh, Srinivas Reddy, Srujana, everyone. Thank you so much for joining the call today. Thank you. Yep. Any more questions, please? I'll wait. Do you hear me? I don't see anyone here. I don't hear anyone actually. Do you hear me, please? Am I audible?
Yes,
Yes, sir.
Yeah,
Yes.
thank you. Thank you so
Thank
much.
you.
Yes,
Okay.
sir. Yes, sir.
Thank you. Have a nice time. Thank
All
you.
right.
Sir.
All right.
Yeah.
Thank you. Bye-bye.
You're welcome. Thank you so much, everyone. Thank you. Bye. Thank you. Just closing the windows here. I'll send you all these notes. Thank you so much. Thank you so much. Just WhatsApp me, ping me on WhatsApp, and I'll take it from there anyway. I'll add it to the WhatsApp channel exclusively for Databricks content. Thank you so much. Have a nice time. Thank you. I'll close the window. Thank you so much.
Thank you, sir. Thank you so much, sir.
Thank you, friends. Thank you. Thank you. Bye. Thank you, everyone. Yep. Just closing the window here. Thank you so much. Have a nice time. Yep. I'll include this Word document along with the class notes anyway. I'll do.